Welcome Math 107 students to the demo section of Lesson 9, where we're looking at other types of equations and inequalities. Sections 1.6 and 1.7 in your textbooks. The first type of equation we're going to look at is called a radical equation. And a radical equation has a radical in it, just as the name implies. The key to solving a radical equation is to get the term with the radical expression in it on one side of your equation and everything else on the other side. The mathematical language we use for that is to isolate the radical. Okay, so when we isolate the radical, it's just the expression with your variable, let's say x, and then whatever particular radical you happen to be taking. So I'm just going to put an n there. The number that's out front is always a 1, whether we write the 1 or not. So if there's a number multiplying this radical like 3, you would divide both sides by 3, and then it would be isolated. If there's a number that's being attached to it like 6, then you would subtract 6 from both sides. So the key here is to get the square root of x or the third root of x or whatever root you're looking at of your variable all by itself on one side of the equation. So let's take a look at this first equation. We notice that the square root of x is what we want to isolate. It already has a 1 multiplying it since we don't see any number out front. So all we have to do is remove the addition of x to the square root of x. So we're going to subtract x from both sides of the equation. And we're left with the square root of x equals 12 take away x. So this is an equivalent equation to the one we started with. And as I've mentioned before, we want to put parentheses around the 12 minus x so that we see that as a single quantity. And if we end up having to multiply it or apply an exponent to it, then we make sure we do it properly. Now our goal is to get x equals something. And right now we have the square root of x. So the way we get to x is we undo the square root of x by squaring it. When we square the square root of x, the squaring and the square root, since they're inverses of each other, brings us back to x. But remember, whatever you do to one side, you must do to the other side. Now the right-hand side is a binomial, 12 minus x, it's two terms being squared. So you've got to be really careful here and not use inappropriately an exponent property because this is subtraction, the base is subtraction. So you want to multiply this out using the definition of what it means to square a quantity and then apply your distributive property twice. So we get x equals 144 minus 12x minus 12x plus x squared. When we simplify the like terms on the right-hand side, we get 144 minus 24x plus x squared. Typically, we usually rearrange the expression on the right-hand side so that you have your highest power first, our quadratic term, that's what we call x squared. And then negative 24x is our linear term, and then 144 is our constant term. So now we have what we call a quadratic equation to solve. And the good news is we've just spent a couple of sections learning how to solve quadratic equations. So we know we have to subtract x from both sides because we have to have 0 on one side of our quadratic equation in order to solve it. So when I subtract x from both sides, 1x, I get 0 equals x squared minus 25x plus 144. Let's move up to the top of the page. So I have 0 equals x squared minus 25x plus 144. So some of you may want to use your quadratic formula, since we know the quadratic formula will solve any quadratic equation set equal to 0. Or if possible, if we can factor it, that's going to be really quick and easy. So I'm wondering if there's factors of 144 that add up to 25. And yes, indeed, there are two numbers I can multiply that give me 144 and add up to 25, and that's 16 and 9. And since I have a positive 144, both of these factors have to either be both addition or subtraction, and as you know, you look at the sign of the middle term, and that tells you that they're both subtraction. Now, to solve this quadratic, I set each factor equal to 0, and now I have two baby linear equations, and I arrive at two potential solutions. Notice I said potential, because anytime we have a radical equation and we end up raising both sides to a power like we just did of 2 and squaring it, we create an equation that's, in this case, quadratic, which has two potential solutions. It doesn't mean the original equation has those two solutions, so you always have to check. So let's check 9 first. So we're going to check out 9, and we get 9 plus the square root of 9. Does that equal 12? 9 plus 3 is 12. 12 is 12. You're a happy camper. That works. Now we want to check out our other answer. 16 plus the square root of 16. Does that equal 12? 16 plus 4 does not equal 12. So this is not a solution to the original equation. We call this extraneous. That's the word we give it in mathematics. And later on, I will show you when we get into functions what this equation looks like if we were to graph it with GeoGebra compared to this equation. So you can see how this extraneous solution works for this equation, but not this one. Okay, the other little thing I wanted to do for those of you who think that factoring is really difficult, and if you have a graphing calculator or even just any calculator, how did I find the factors of 144 so quickly that added up to 25? So what I do on a graphing calculator, and those of you, and again, you could do this on any calculator you want, but this kind of does it quickly for you. So what I do is I take 144 and I divide it by x. And because I'm trying to find all of the different factors of 144, and in particular, I'm trying to find the pair of factors that adds up to 25. So then I set my table to start at 1, and then I just look at my table. So you can see the very first x value is 1, so its partner is 144, and if you were to add those, you'd get 145 for your middle term. And as you go down, you can see that, of course, not every integer is going to have its partner being another integer, so you don't have to pay any attention to the y1s that are not integers. So as you go along here, you can see 4 and 36 add up to 40, and 6 and 24 add up to 30. You're getting closer. And as you go down, 8 times 18, oh, you're getting really close, because 8 plus 18 is 26. And then lo and behold, there's your next pair, 9 times 16, that adds up to 25. So if you have a calculator available, you can use that to help you out with some factoring. Just thought you might like to see that little handy dandy trick with your calculator. So remember that when you have a radical equation, it's mandatory to check your solutions. Now, equations with rational exponents aren't that much different than equations with radicals. So again, the key is to isolate the term with your rational exponent on one side of your equation, get all of your other terms onto the other side of the equation. So in this case, we want x to the 2/3 all by itself. So I'm going to add 8 to both sides of the equation. So we get x to the 2/3 equals 12. Okay, oops. X to the 2/3 equals 4, because that's a -4 there plus 8. Okay, so if you recall our preview activity, what we would like to do is to get x to the first power equals some number. That's our goal. So we have to figure out, just like we did in the problem above, when we had the square root of x, we could raise both sides to the second power to undo the square root. Well, we have to undo a cubed root and we have to undo a squaring here. So we want to figure out what power to raise this power to so we get x to the first. And you'll remember that that power is the reciprocal, 3/2. So I am going to raise both sides of this equation to the 3/2 power. And what I get on the left side is x to the 6/6, which of course is x to the first. So we're not going to bother writing in x to the 6/6. We're going to say, a lot of times you see students do this kind of thing. And you have x here, and now you have 4 raised to the 3/2 power. Now before you start to simplify this, one little thing you have to be aware of is when the numerator in your original problem is even, once we take the reciprocal, you're going to end up taking an even root. So in this case, it's a square root. And remember, the square root of 4 has 2 answers. It's +2 and -2. So you have to remember that when you take an even root of a number, you get 2 answers. So you're going to get the square root of 4 is 2 and it's -2. So when we apply the even root first, we get 2 answers, and now we cube both of them. So there are our 2 solutions, x equals 8 and x equals -8. So your solution set would be -8 first and 8 second. You can always check your answers. We go back, 8 to the 2/3 minus 8 equals -4. The cubed root of 8 is 2. When I square it, I get 4. 4 take away 8 equals -4. -4 equals -4. So 8 checks. And I'll leave this one for you to check. -8 to the 2/3 minus 8 equals -4. Okay. So that's radical equations and equations with rational exponents. Now, if this had said x to the 3/4 instead of 2/3 here, then you wouldn't have to worry about the plus and minus. It's only when in your original equation the numerator is an even power, because then remember that numerator will become the denominator, and so you'll be taking an even root. So we found both solutions here. So also note that checking your answers to equations with fractional powers is mandatory as well, and sometimes you can end up with an extraneous solution. Okay, so let's take a look at inequalities. Linear inequalities. The key to solving a linear inequality is you treat it just like it's an equation with one small difference. Whenever you end up doing the very last step when you're solving for x or whatever your variable is, if you're multiplying or dividing both sides by a negative number, you have to reverse the sign of the inequality. So if you look at this first inequality, it says -4 times x is less than 8. So if this were an equation, if this said -4x equals 8, you would divide both sides by -4. So proceed as if you were solving an equation. And you get x on this side and -2 on this side. The difference now is that you have to reverse the sign of that inequality, x greater than -2. So if you were working on a number line, you would put an open circle at -2, and then you would shade it all the way to the right. So this is a really quick check you can do. If you forget to do this and you had x equals -2, for example, x is less than -2, pick a number out in this area, like -5, and if you check x equals -5 into your original inequality, 20 is not less than 8. No, doesn't work. Okay, so it's always important that you check your answers to equations and inequalities, particularly when you have these negative numbers that you're multiplying and dividing both sides by, so that if you do forget it, you can always do a real quick check by taking a number from whatever your answer is here and seeing if it works or not. So if we actually checked an answer from this solution set here, any number greater than -2. Let's say we're going to pick -10, and we put -10 in, excuse me, +10. We put +10 in for x. We can see that -40 is definitely less than 8, and we're happy. We've picked the right direction for our inequality. All right, so it says, write your answer using set builder notation. Well, it's probably been a little while since you've thought of that. So x being greater than -2 is x, the set of all x such that x is greater than -2. That's your set builder notation. This is your number line. And then interval notation, since we're not including -2, we would start with a negative, with a parenthesis, have -2, comma, and infinity, parenthesis. So this is interval. This is set builder. And this is a number line. So all three of these are a way to represent this infinite solution set for this inequality. Okay, sometimes we get to put two inequalities together in one inequality, sort of like a compound sentence. Linda went to GCC and then she went home. So I took two full sentences and combined them with and. So in the old days, we called that a compound sentence. So the key to solving a compound inequality is to treat it like an equation that has three sides. Whatever you do to one of the three pieces, you must do to all of the three pieces. So your goal is to isolate x in the middle. So right now, if you look at the middle right here, and you think of that as x minus 4, and if you just cover up the, say, the left-hand side of this, and I was trying to look for something really quickly to cover this up with. Let's say I cover this up right here, and then of course I have to fill it in. So let's say if I can do this quickly. I don't think I can, and I don't want to have to redo this all over again. So let's just remove what I was just trying to cover that up. So we have x minus 4. We want x all by itself in the middle. So just like we were solving an equation, we would add 4, but instead of having just one side to add 4 to, we have two sides. So the equation has almost three sides, three pieces, however you want to think about it. So you put your straight line there and you say -6 plus 4 is 2. Since I added a number to each side, I don't have to worry about changing the direction of my inequality. And there's my answer. X is less than or equal to 5 and greater than or equal to 2. You read this by focusing on the middle, and you read left to right. X is less than or equal to 5, and then you go right to left, x is greater than 2, or you could read right to left and then left to right, x is greater than or equal to 2, and x is less than or equal to 5. So on a number line, it looks like this. You have 2, and you have 5, and you have an open circle at 2, and you shade all of the millions and zillions of numbers in between 2 and 5, and you have a closed circle at 5. Your book often will use this notation similar to interval. They'll put a parenthesis there and a staple. I call this a staple, the bracket at 5, and then it shades everything in between there. Okay, so that's what it looks like on the number line. This is what it looks like in interval notation, which is what my math lab will ask you to do for the solution set. So that's how you solve a compound linear inequality. If that is difficult for you, then what you can do is you can just separate the two pieces. You can say x minus 4 is greater than -6, and then you can say x minus 4 is less than or equal to 1. and just solve each of these as we did before. If it's easier for you to keep it as two separate inequalities, that's okay. Oh, I just saw that I made a mistake over here. Ooh, that's good. This is -2. I'm sorry. So there should be a -2, a -2, and a -2. So now we get x is greater than -2. That's what this says. X is greater than -2, and this says x is less than or equal to 5. So our solution set is parentheses, -2, 5, and interval notation. If you have any questions, let me know. I'll be glad to answer them.